Thank you very much, everyone, for coming. My name is Marek. I, for some reason, was asked to do this today. Last year, I did this multilingual natural language processing. Is it solved? Since we have all these ChatGPTs and whatnot. And so this year, I thought we would do a sort of what's happened in the year, sort of a refresher, and perhaps maybe show some of our work as part of that as well. Before we start, I do think it bears it bears repeating once again. When you sort of get invited to something like this, you get this sort of an email from Docent Gruska, which is like the first 10 minutes should be motivational and everyone should understand. That's been the 7 minutes we tried, to connect, plus so you have like 90 seconds of motivational stuff. Then it should be sort of 10 minutes that, majority of people will understand, and the last 15 minutes, your spiel is from what I answer, is what I sort of understood it as. So I tried to kind of follow that structure, and we'll see where we, it's still 120 slides to go, so we'll see. Anyhow, I guess many of you might have seen me previously, and if that's the case, we'll go through this quickly, but on the off chance you have not, I sort of do some stuff still at this thing called Slido, which I sort of brought the t-shirt of, which this cannot be me. All right. Which is this audience interaction platform we'll hopefully even use today. I also sort of teach here and partially also organize this RoboCup thing, where kids play, or like even bigger kids who are so-called university professors play soccer with robots. So very cool stuff. None of that matters because for the past 3 years I've been basically a sort of fortune teller of this sort of a thing. And last year my spiel sort of started with this, that it was strange how ChatGPT managed to sprint to 1 million users. It was even more strange how it managed to sprint to 100 million users, which it took only 5 months to get to. In the interest of updating the thing, we are in February 2025, and the open source things you can find is that they managed to basically go to four times that much. And the big interesting thing is how does that happen? What's the reason for it apart from it being able to quickly, effectively do large scale, or as Chomsky would say, industry scale, industry scale infringement. Look, the part of it might have been that they started to do these searchy things, which is that you go to ChatGPT, you sort of search for something, it tries to search for these things and then give you the result sort of answer, in some sort of a coherent answer. It's probably not that. The open source, again, the open numbers that you can find will show you something like this. The amount of searches that people do through ChatGPT is still relatively minuscule. The reason why I like this particular picture is that DuckDuckGo in here is a thing where I spent another 6 years at. It took 12, 14 years for DuckDuckGo to get to a point where where it gets to be queried about 100 million times a day. ChatGPT that's still in years. But as you can see, the Google queries massively dominate. So it's probably not that. And if it's not that, it's got to be something else. And we'll go try to figure that out. What might be this something else? And here is what Anderson Horowitz, one of the big VC firms who do a bit of a sort of analysis in this field, think that it might be caused by. The November 2022 is the time where ChatGPT was launched for the first time. In about, I believe, February something, GPT-4 was launched, and then sort of the monthly unique visits plateaued a bit. You can see a bit of a significant drop in June, July, August. Guess why? That actually is visible in here as well. So it's sort of it does seem like the sort of student demographic uses it quite heavily. But the interesting thing that, as we can probably all see in here, the interesting thing in here is that something happened in April 2024. That's right about where we discussed this last time. And then there are these things in rollout of advanced voice mode. I wish we had time for that. We won't, but we certainly will try to at least discuss this O1 thing, which seems to have sort of propelled the growth of ChatGPT in the past, at least couple of last months. this GPT-4o, I'm not sure if you heard about it, and I wish again I had more time, but I don't. So I'll just mention that it's a sort of, it tries to be the O in there, tries to be sort of omni model, whereas the previous GPT models only took text as the input, or the sort of tokenized representation of text as the input. This 4o is supposed to take the tokenized representation of anything as an output, and ultimately take everything like any modality as its input, and ultimately output any modality as its output. Anyone were thinking like, what's that good for? So again, seeing how Dr. Gruska hasn't really picked the things I thought were most interesting. Look, this is a headshot picture I've been using for like 6 years now, or something like that. So I was thinking, what are the things GPT-4o might be good for? Something like this. It can easily convert this into a cartoon, into a 3D cartoon as well. My wife doesn't like this one too much. It can do various interesting styles. Like this is a sort of puppet show style of a representation. This thing is sort of the Wallace and Gromit, or you know, what's the other? Shaun the Sheep, I think, is the other fairy tale that this comes from. And it can certainly do Lego, which is perhaps the funniest part, at least the sort of most favorite one of my nephew. What I'm trying to say by that is that, like, notice the Slido part that it sort of outlines in here. It does that down to the font, which is not down to the font face, which is incredibly good. If you feel free to try that with some sort of a diffusion model, this tends to be auto-regressive. So it seems like that there is some user potential in here for things that might kind of capture the attention, and with that we would finish the everyone should understand part. But unfortunately, we'll probably have to skip that through. So my bigger point in here is that the although it might look interesting, again, like might look like things that haven't been possible are now possible, and like this sort of just came out of the blue. It's the absolute opposite is the case. Here I sort of tried to do the same list as last time. Have a list of things that happened that sort of precluded the current sort of frontiers of neural network, of sequential processing with neural networks, which is what this has been called before it got bungled up into this bigger term called AI. And the interesting thing this year probably is that we'll have to split last year into two categories: the GPT-4o part, and then perhaps the reasoning models we'll talk about slightly more, probably in the next couple of minutes. So the kind of the split that I wanted to make in this point is that we are probably going into the golden age of what we would call reasoning models, and I'll try my best to run you through what these would be, or what these are. Reasoning models, friends. It's like this. Last time we discussed this. That basically, knowing how to ask these models is where much of the value of them comes from. The name of the game is called guess what was in my training set, because these sort of things. I mean, the actual joke around the blog is that all you need is to train on the test set. So in that sense, if you know how to get the test set out of the model by some interesting by some interesting way of asking the models, that's all that you really need to do. That's also probably what in here will probably differentiate the sort of students who just sort of throw the assignment into the thing and hope something comes out, from those that actually will try to kind of mingle it in at least a bit. So the standard prompting would be you ask it a question, you hope it answers correctly, and a multitude of problems come out. The chain of thought approach would be if we happen to have sort of a reasoning we can provide the model in the as an example, it will easily pick up that it might make sense to do this reasoning thing, meaning output things like, okay, what do I know about the problem? Try to sort of pick it together, and so on and so forth, and via doing that, arrive hopefully at a better answer. It turns out it does help. It turns out you can do this semi-automatically. Here's how you would do that. You would sort of try to prompt the model to sort of on its own output the reasoning steps, output the things that it thinks are relevant to solve the problem, and therefore sort of provide the answer. That would be the prompting approach. What we discussed last time is that it matters what you ask it to do. Let's think step by step was one of the most famous ones. Last year, it turns out, take a deep breath and work on the problem step by step would be even better, probably. But that's not what we are here for. What we are here for is this. OpenAI in September last year released this thing. The GPT-4o is a sort of model that you can prompt easily via sort of asking these interesting or intricate questions. The O1 model, though, on this sort of a problem, like these sort of tasks, completely obliterated it, as in it's significantly better. Similarly on code style problems, as well as the kind of hard sciences or like natural sciences problems. And I was thinking, how do I kind of show you how these things work? I mean, we don't really know, but like at least conceptually visualize how do these things work. And so one of the interesting things that we might want to do would be to take a closer look at this IM competition. The IM competition is what our friends in the US used to choose the representatives for representatives for their international mathematical Olympiad to compete in. And so the whole sort of thinking there is that these are tasks that should be relatively straightforward they are sort of not straightforward. They are quite difficult. They should be straightforward for a PhD level, as they call it at least, for a PhD level student to pick up. For a high schooler, it's relatively it's like fairly challenging, yet should be solvable. And at the same time, the answer is always in between 0 and 1,000. Inclusive. So, in that sense, it sort of leads itself into relatively nice way of kind of making sure that like these things are solvable. Here's one of these sort of tasks that these IM problems would include. Just things like for real numbers x and y, both greater than 1. Such that the log x of y to the x is equal to log y of x to the 4y equals 10. Find the multiplication of x and y, right? Like and like now you would probably go exactly as the solution outlines over there. You would probably go and sort of try to reason from first principles. What are the kind of attributes of logarithms that you can use to kind of go about solving something like this? There are a couple of solutions, maybe like 6 or 8, directly on this website, which will be probably relevant. And so let's try and see what a model that has been sort of trained to do things like this, to do this reasoning, would sort of tell us about it. And I just hope we don't run into an out of memory, not even out of memory, but like out of GP problem. If we do, we'll do it somewhat differently. No? All right. We don't have time, unfortunately. But the bigger thing that I wanted to kind of show you is that the way these models kind of will jump up from the GPT-4o to the O1 level would be by effectively outlining much of the reasoning on their own, as in without being prompted to think step by step, without being forced to kind of with this intricate, let's take a deep breath and whatever, to kind of being induced into the state of thinking. They would be thinking straight up, and only after they did a bit of thinking, as we would call it, they would do. Yeah, so I thought they would actually get the answer out. The problem here is that what they report in here, the shaded regions are, and let's quote, the performance of majority vote the consensus with 64 samples. And if I take 64 samples, I don't think I actually need a language model. I know you cannot really see it, but all this does is basically. Let's try again. No? Okay. All this does is basically random choice and gets 80% on the whole thing. So what I'm trying to say in here that things like these, since these are while in here you have to guess a number from 0 to 1,000. In here it's one of 4 to 8 options. So in other words, if I get enough passes at some and all I take is majority vote, at some point I win just by the sheer randomness. That being said, there is something to it. Mostly because the way the reasoning models work. Not today, it seems. All right. The way the reasoning models work will kind of lends itself into the nature of the more tokens I have, like on the output, it seems at least the higher accuracy I can get, even if I do a single pass. So in other words, if they sort of give the model a bigger amount of compute and training, meaning I can train it for longer because I have unlimited amount of tokens I have seen all of the internet effectively and can make use of that. That helps slightly, but what helps significantly is if I at test time make it so that the model sort of thinks for longer and longer. This will end up being relatively important. Now, how do we get into something like that? No one knows. OpenAI is no longer open. Neither do we know whether it's AI really. But there is certainly sort of desire to get that done. It turns out it's kind of a reproduction actually comes from very unexpected place of all things, from a place called DeepSeek. Before we do that, I want to highlight that OpenAI released O1 on the all right, O1 released in September, but there was another release called O3 in December, and with that we go into the I work at this audience interaction company, so we better have some introduction. We better have some interaction. So I'd like you to type slido.com into your devices, and we'll do a quick quiz. And to entice you to do that, I have 3 books you can win. Either the little book of deep learning, the most important thing, you can grab out of in here. The Why Greatness Cannot Be Planned. Another very good book. It's a very nice reinforcement learning result, applicable in your life as well. Or if you are sort of in that position, also the best leadership book I can recommend, Turn Leadership Around. So one of these can be yours. Please join us in, and we'll be doing a quiz. So please type your name in so that we can identify you somehow. I believe we have like 20 people in the room, so we'll wait for a while. I am very sorry to whoever is online. Cool, 15, that's great. 16. I'll take it. Okay. Thank you very much. So 3, 2, 1. The very first question of the quiz is: why is the OpenAI's next model after O1 not called O2? It was actually called O3. And many of these might be possible, just one is correct. Why O2? Why not O2? That's really a first, but it probably works better with an American audience where I did this for the first time. But yes, O2 was already trademarked. It turns out even OpenAI, with its big offers of hundreds of billions of dollars, wasn't willing to buy out the Telefonica O2 conglomerate. So they did release O3, which is sort of a different model, not massively different from what O1 does, but it seems to be a distillation. They did that on, I believe, 20th of December. On 25th of December, DeepSeek pops up. DeepSeek is a sort of the the absolute sort of like it looks like a nothing burger, yet it ends up pulling very good numbers in many benchmarks. It's a 635 billion parameter model that's just released on Hugging Face without as much of a README. Like it's basically just weights, but it ends up working pretty well. Again, mixture of experts model and so on and so forth. What's even interesting is what happens on 20th of January, not even a month later, which is when DeepSeek releases R1, which ends up being a kind of a much smaller model, but it turns out at least as capable one, if not even more. And so on one of the things that it did was this. This is NVIDIA price on the 27th, 25th when they released it was I believe Friday. Yes, Friday after hours or already Saturday. On Monday, this is what NVIDIA stock price looked like. This is what the drop of market cap looked like. 600 billion. That's 3 Slovakias, I believe, in GDP. And so with that, the next question on the quiz is. The next question on the quiz is this was correct. The next question is, what was the estimated total cost of developing something like this DeepSeek R1? And it might have seen the sort of some of the headlines said 95% of cost of the bigger models. Cool. So this worked way better. The analyst, the industry analyst, going from the paper and from the amount of GPU hours they outline in the paper. Actually, that's interesting. For like again frontier model, and actually has a paper. That's a new one for sure in the past year. They did really sort of compute renting power of that to like renting cost of it on the market to be about 6 million. That only turned out to be the very final fine tuning. So the total cost was very likely way up. So whoever picked 1.6 billion got it. Sort of at least would agree with me. It was a tricky question though, so I don't feel too bad about it. That being said, in the paper itself is an interesting one to read. It kind of shows you how to get very close to O1. The O1 performance. I wish I had more time, but we don't, so I'll just run you through on high level how that works. Look, the first thing to see, which is, do we get something in here? We did. What these things do is that they output these thinking tokens normally when you ask them questions like this. It literally looks like it thinking to itself. Okay, so I need to find a product, blah 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 blah, and then I can apply blah 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 blah. So maybe I can simplify these equations using these properties, blah blah blah. So we have something like this, and so on, and like let's substitute that into equation, and like this is interesting. So from equation 1, x is 10a. Let's plug x equals 10a into the equation. Wait, but equation 2 has a y. Let me see. And so it's like it's as if like someone not really sensible. Do I say like someone like as if someone was really had this sort of internal monologue going on in there. Many people have asked me like, how is that implemented? So friends, let me show you. It's absolutely straightforward. It's literally part of that prompt. Like you will. What it's asked to do is the reasoning process and answer are enclosed within think and end think and answer and end answer tags, respectively. Think, reasoning process here, answer here. Thank you very much. That's the prompt. All right. So like in a sense, like is this like this is a hack at best, if not even worse. The actual interesting thing is in how they do the reinforcement learning on it. It turns out the accuracy rewards they use are effectively, have I completely solved some coding problem down to having all the test cases pass? In other words, if the standard problem of how do we make it so that like someone evaluates what's the value of the current solution goes away, mostly because you have all these test cases that they evaluate on. So in other words, this sort of reasoning with this weight that let me see ends up being kind of inducible into the model just by sort of optimizing it to solve coding tasks, it turns out. Cool. Here's what it looks like during training. It can really break the O1 barrier, and this is kind of the most important meme of that paper, where they sort of show this sort of interesting aha moment of the kind of version that they've been training, which is like it started to solve some problem, and it goes rearrange to isolate the inner square root term, blah 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 blah. And then it thinks, and then it says, wait. That's an aha moment I can flag in here. And so like, this is what we get, ladies and gentlemen. We are now sort of hoping a model would have an, aha moment. So in that sense, if we thought it understood previously, we understand less and less and less. But it seems that things like these, where we globally, like in groups, that the actual reinforcement learning method is called GRPO. So they do that. They do this in groups. It kind of actually does seem to work. Even with very small models, you can try that on your own. But it's interesting that we end up in this wait territory. The weight ends up being important for something like this. DeepSeek is interesting, but it cannot, at least in its vanilla version, it cannot reproduce these things which OpenAI had. The more thinking token I give you, the better the thinking process, right? Like the higher the accuracy or higher the performance on some sort of a task. For that, we would need this, a very simple, very nice paper by Nicholas, currently at Stanford. The only reason I'm showing that is what sort of the state of the art in this kind of an area looks like. State of the art is like this. OpenAI seems to be able to scale linearly. Open weights do not seem to be scaling linearly. Can we get a hack or two together so that we can scale linearly as well? Obviously we can. That's why this is a leading question. But for that, we'll have to go quickly through some background in the past time. We did discuss this, and so I will assume this is sort of understandable that on an absolute higher level, it's effectively this whole language model thing is effectively a kind of autocomplete that's been trained on all of the internet, and then the interesting thing is how do we kind of pick what the next word is, right? Like we have a choice in here, or the language models have to make that choice somehow. They do that in multiple ways. Some of them end up being very boring. Some of them end up being slightly better. But the best ones that are normally used, called nucleus sampling, will try to balance out the fact that you will have both narrow and very wide and very narrow distributions of the tokens of their probabilities. Now, when you do that, at some point you end this thinking process, and this whole thinking will either take, like, you don't really control how long it's going to take. What you're seeing in here is that the number of tokens that, for instance, Gemini, another very strong model from Google, sort of takes which Gemini is one of the models Misha Valko has been working on. That ends up sort of trying to compress the amount of tokens that uses to output the answer. Whereas this R1 model will easily and happily go to long lengths to do this sort of internal monologue discussions, and that ends up being important if you're trying to sort of scale with the amount of tokens you have available. And so the actual hack that ends up being interesting is as follows: when you get a question like how many are there in Raspberry, and this is sort of what the model would answer, something like yes. So I'll go word by word and try to sort of count it somewhere. The sort of sampling mechanism is still something we ourselves choose if we have the access to the model weights. So in other words, if we have if we can get to to somewhere in here where the model basically says, I'm done. What we can do is to do what they call budget forcing, which is instead of it saying, okay, I have the end of the answer, remove that token completely and do wait and let it think further. So in other words, all this thing does is that whenever I still have tokens I can make use of, I'll force the model to output more and more of these, more and more of them, and hope for the best. The best actually does help relatively significantly. As you can see, the O1 models, like which we don't know on how many examples they've been trained, are effectively on par on some tasks with these sort of smallish models. These have been trained on like 1,000 very specific examples, but just 1,000 of them. And like using this budget forcing thing, are able to sort of reproduce the very same or very similar performance. So all in all, it does seem like this sort of reasoning thing does help. And to finish this off, this part off, I have the final question in the quiz, and the final question is, how on earth was this DeepSeek's DeepSeek able to do that? Man, this is 10 out of 10. All right. All right, once again, how on earth was this DeepSeek able to, undercut these massive labs when it comes to, oh come on, when it comes to funding? Worked way better on my computer, that's for sure. Oh man. It looks like that. Anyway, I'll finish it off. It turns out that it was a hedge fund that actually was the parent of the company that ended up doing this DeepSeek model. My personal take: if you are a hedge fund and you know how to make money on the stock market, the first thing I would do would be to short Nvidia if I had a model like this. So who knows? Maybe that's what they did. All right, Martin H. Congratulations. Feel free to pick the book afterwards. And I'll try to finish this off because it looks like we have like 7 minutes and 70 slides. All right. So with that, I wanted to do. I was thinking I would do a bit of an intermezzo. We'll skip right through that. I'll try my best to show you a couple of new work that we've been working on. We've been working on in here. Much of what I was trying to say by this has already been either published or will be published very soon. So one of the big problems that we had with multilingual NLP, basically in the past, and specifically the Slovak language in it, is that Slovak was never ever part of like big benchmarks. It was completely ignored for various reasons. It's very close to Czech, which is sort of a relatively okay result, understandable thing. But much more importantly, it also did not really have many data sets that you could make use of. That's thankfully changing. One of the examples is MMTAP, Massive Multilingual Text Embedding Benchmark. Slovak got in there with a couple of tasks. I got to be on the authors list by some random coincidence. This has been accepted to the very same conference. The paper by Dr. Boža and future Dr. Macko has been accepted as well. I mean, there were two authors. I'm one of 70 or whatever. So it's like I'm not trying to claim credit in here, but I'd say it's a relatively big thing that that this ended up happening. Just single result from there. It turns out if you are multilingual, if you have a lot of languages to train on, you can not easily, but you can beat, even with smaller models on the order of 500 parameters, you can beat models that have like 7 billion parameters on the very same tasks that this sort of a benchmark has. If it hasn't happened, if this sort of a big benchmark hasn't happened, like this sort of an author result is impossible to obtain. So that's one thing. Another thing that's currently being reviewed, and if we play the rebuttal game well, might get accepted as well to the ACL conference is CLEP. Is the Slovak General Language Understanding benchmark. It's an attempt of us to make it so that Slovak is on par of the sort of languages around us, to be able to automatically test to what extent do models, specifically the encoder models, do on it. We gathered quite a few data sets. It's a sort of standard 9 of them. This is similar to the standard glue benchmarks. Some of these we had to kind of recreate ourselves. Some of these we had to translate. For those that we had to translate, we ran a kind of translation study. This is again something you can take off. If you need a very precise translation of Slovak text, a very precise translation from English to Slovak, the best thing we found on the market is DeepL. But GPT-4o, with a very simple prompt, translating this to Slovak works just as well and costs one-tenth of the price. So I would encourage you to try that out. And when you do, we benchmarked like 14 models on all of these. There has been a massive, a very massive hyperparameter sweep that went into it. Unfortunately, what it sort of showed, the whole thing, is that the actual, like, compared to Slovak BERT, which is like 4 years old now, the only model that is sort of to some extent like significantly better would be the XLMR Roberta, the large version. So it seems like that it's just the size that helped in here. That's when we take a look at the relative improvements. When we take a look at the absolute values, the MDBERTA, which is the Microsoft model, latest multilingual version one, kind of works quite a bit, quite well. But there's significant, like at 72.6, there's still significant room for improvement. So with that, the sort of summary is, we are still far from being done. The tide has thankfully shifted for things like Slovak. Lots of interesting things are being culminating together, except for the internet in here. Data is still the limiting factor, and I think we ran out of the internet data, so we'll have to take a look somewhere else. And next time we speak, I hope we'll have some models to present as well. So with that, thank you very much. I think we ran out of energy, time, options, and all that. So I guess the next thing on the agenda is, the department meeting in 3 minutes. Thanks again for bearing one.